friends, I welcome you all for another lecture on the course Microprocessors and Microcontrollers. In today's class, I am going to discuss about a concept I/O ports of PIC 16F877 controller. In the last class, we discussed about the architecture of PIC 16F877 controller. In that, I raised one point regarding to I/O ports. That is, PIC 16F877 has total 33 I/O pins. Those 33 pins are organized in 5 I/O ports. Those are port A, port B, port C, port D, and port E. Again, that time I was discuss little bit about these 5 ports. Port A size is a 6-bit I/O port, which may have 6 pins. Those are RA02, RA5. Next, port E has just only 3 pins. It is a 3-bit I/O port. Those 3 pins are RA02, RA2, and remaining 3 ports, that is port B, port C, and port D. Each port size is equivalent to 8-bit. Under port A, there are 8 signals. Those are like this. So under port B, there are 8 signals like this. RB02, RB7. Under port C, again 8 pins. Those are RC02, RC7. Under port D, we have 8 signals. Those are RD02, RD7. So that I was discussed in the last concept. The continuation of that I am going to discuss today. That means I am going to discuss much more about the I/O ports which are present in this PIC 16F877 controller. Right. So my first point is PIC 16F877 supports 5 I/O ports. These are port A, port B, port C, port D, and port E. And one more point here I would like to mention, that is this particular PIC 16F877 has total 33 I/O pins. These 33 I/O pins are organized. These are 5 I/O ports. That you have to remember, friends. First, port A of size 8-bit. So that's why port A is 6-bit wide. Port E is 3-bit wide. And remaining ports, that is port B, C, and D, size or wide is equivalent to 8-bit. So from 3 ports, 3 8s are 24. From port A we are getting 6 pins, 24 plus 6, 30. And from port E you may get 3 more signals, total 33 I/O pins from this 5 I/O ports. And next, each and every port has its own data direction register. For port A, data direction register is TRISA. For port B, it is a TRISB. For port C, it is a TRISC. For port D, it is a TRISB. And for port E, it is TRISC. For each and every port has its own data direction register. These are those 5 data direction registers correspond to the 5 ports of our PIC 16F877 controller. Now, I am going to start my discussion with port A. I have already told you port A is a 16-bit I/O port. So 6-bit I/O port. That means it has a total 6 I/O pins. Those 6 I/O pins are used for the connection of I/O devices. That's why it's called I/O port of size 6-bit. The I/O direction is decided by a data direction register bits, which is a TRISA. This is the data direction register for port A. And next, clearing the TRISA bit will make that particular pin as an output pin. Reading a port A will read pin status, whereas writing port A will write to the port latch. Write operations are always read, modify, write operations. What these are. So one thing I would like to a little bit discussing about this point. So This is my port A. This port has total 6 IO pins like this. That is RA0 to RA5. RA0 to RA5. This is RA0, RA1, RA2, RA3, RA4 and then RA5. Next, to define the direction of this individual IO pins of this port A, we took the help of a register called DDR, which is called data direction register. For this port A, that data direction register name is TRISA. This register size is 6 bits. It is like this. It is like this. Let your connection, this is bit 0 and this was bit 5. By programming of bit 0, that means you clear this 0. We clear this 0 bit of TRISA. The time this port A signal RA0 is defined as output signal. That means the time it is acts like an outward direction signal. If you make a bit here, it is 1. This is a bit 1 of your TRISA. This is the bit is dedicating for a pin RA1. Once this is a 1, no doubt this particular signal is defined as input signal. That is the meaning of this. That means I can go and program the port A signals RA0 to RA5 individually, either as input signals or output signals, with the help of TRISA bits. That's you have to remember. That's the meaning of this second point. And coming to the next, reading the information from the port. That means we are reading the information from this pin status. We are reading from this. We are reading from this. But if we are writing something, we are writing the information onto port latch. We are writing the information onto port latch. That's the meaning of this second point. And third point and last point is always write operations are read to modify write. That means first you have to read the information from the pins of this port. Later you have to modify it because we are going to do a write operation. After modification only, then what all the information if you want to write in the latch of the corresponding port, we can go. So that's why here we clearly says that the write operations of this particular port is read, modify, write. That is the meaning of these points. And next, port A has alternate functions for their pins. Port A have an alternate functions because on port A you may have RA0, RA1, RA2, RA3, RA4, RA5. Basically these 6 pins are used for the connection of IO device. These pins have an alternate function. In that this RA4 is also act as T0 CKI. That means timer 0 clock input. That means whenever if you want to use timer 0 act as a counter, the time timer 0 has to get a clock signal from an external world. The time it took the help of a pin called T0 CKI. That means a timer 0 clock input. So the alternate function of RA4 of your port A is T0 CKI. So this is an alternate function. And coming to remaining 5 signals have an alternate function, that is, these remaining 5 signals may act as analog to digital converter input signals. What are the ADC we have? In case of our PIC 16F877, which is 8 channel 10-bit ADC. That means that ADC can go and collect 8 analog inputs from 8 different places. In that purpose, it will go and take the help of 8 analog inputs. So that time, it will go and use this port A signals for that. This RA0 is act as AIN0 and this RA1 is act as AIN1. This RA2 is act as AIN2 and this RA3 is act as AIN3 and this RA5 is act as AIN4. Here AIN means analog input. So with the help of these 5 signals, your ADC will get 8 different analog signals from external world. So these are the alternate functions for port A signals that you have to remember, friends. That means all the pins of port A have alternate functions. So RA0 to RA3 and RA5 may act as analog input signals. These are input signals for internal ADC. And RA4 is act as a T0 CKI. That means a timer 0 clock input. Whenever timer 0 is act as a counter, the time it will collect the clock signals from an external world with the help of that signal T0 CKI. So this is about your port A. And coming to port B. Port B is an 8-bit port. Already we discussed about this just now. Your port B size is 8-bit port. That means it has 8 I/O pins. Those 8 I/O pins are RB02, RB7. There are 8 I/O pins under port B. Again, these 8 signals are used for the connection of I/O devices. And coming to the next one, in order to program this RB0 to RB7, either as an input signals or an output signals separately, we took the help of a data direction register, which is a dedicating to port B, was a TRISD. By using TRISD, it is an 8-bit register. By using this TRISD bits, I can go and program my port B signals RB0 to RB7 either as input signals or an output signals. If a bit in a TRISD is set to 0, its corresponding pin in that port B is defined as an output signal. If a particular bit in TRISD is set to logic 1, its corresponding pin in a port B is defined as input signal. That's the meaning of this. And coming to the next. So that's what I'm saying about programming of port B signals with the help of DDR. Alternate functions of port B signals. Alternate functions of port B signals. Some of the port B signals have an alternate functions. In that process, these are some of the port B signals are used for low voltage programming. For low voltage programming purpose, we took the help of some of port B signals. Here, if you see that RB3 alternate function is PGM and RB6 PGC and RB7 has PGD. PG represents programming. Okay, low voltage programming signals, that is RB3, RB6 and then RB7. And one more signal RB0 have an alternate function. RB0 is act as INT signal. INT signal. That means by using that signal, your PIC 16F877 controller receives the interrupt signals from an external world. It is called as external interrupt signal. Out of 8 signals of port B, 4 signals have an alternate function. That is RB0, RB3, RB6, RB7. RB0 is act as external interrupt signal. RB3 is act as PGM. And RB6 is act as PGZ. And RB7 is act as a PGB. So these are 4 signals have an alternate function. The remaining signals, that is RB1 to RB1, RB2, RB4, RB5, there is no alternate function for these 4 signals of port B. And one more interesting about port B is, this port B may support one more feature, that is, it may generate port B change interrupt. That means whenever the higher order of nibble of port B, that is RB4 to RB7, whenever any signal logic level is changes from 1 to 0 or 0 to 1, automatically port B change interrupt can be generated by this corresponding port. So that's what I mentioned in the last. The port B supports one more important feature of port B change interrupt, in which a state change on any one or more of pins RB7 to RB4 will cause an interrupt, RB change interrupt. So this everyone has to remember about port B. And coming to port C, again port C size also an 8-bit, so it is also an 8-bit I/O port. That means again here also 8 I/O pins, that is PC02, PC02, PC7, 8 signals. This port C is used for the connection of input and output devices. And one more thing is to program these port C signals, either input signals or output signals like port A and port B. It has again its own data direction register which is called PIC. Again, how we are programming this port C signal, either input signal or an output signal with the help of data direction register. It is same as our previous case, port A as well as port B cases. That means any pin of this TRISC, any bit of this TRISC is set to 1. The corresponding pin in a port C is defined as an input, and any bit of this TRISB is clear. The corresponding pin in the port C is defined as an output. So that is the same thing. And alternate functions of this port C is they can do different peripheral functions, because your PIC 16F877 has different peripherals, like it has a CCP ports, that is a capture, compare and PW module ports, and you have user ports, and you have a synchronous serial ports. All these things we consider as peripherals. They are related functions we do with the help of this port C signals. That is considered as an alternate functions of port C. So that you have to remember, friends, about the port C. And next, coming to port D. Again, port D also an 8-bit wide bidirectional IO port. That means again port D has 8 IO pins, that is RD02, RD7. We can use these 8 signals for the connection of input and output devices. Again, to program these 8 signals, either input signals or output signals, again we took the help of data direction register. For this port D, the data direction register is TRISD. Again, any bit of this TRISD is set to 1. The corresponding pin of port D is defined as an input, and any bit of this TRISD is set to 0. The corresponding pin of port D is defined as an output, same as our previous port A, port B, port C cases. So that is an important. And next, this port D have an alternate function, that is, it is act as an 8-bit parallel slave port. It is act as 8-bit parallel slave port. That means this port is used for the connection of IO device. Whenever it is treated as a slave device, these port D signals are used to transfer data in parallel. The time these signals is act as PSP02, PSP7 signals. Parallel slave port signal 02, parallel slave port 7 signal. By using these 8 signals, data parallelly transferred from port D to the selected device, or from a selected device to port D. It is act as a parallel slave port, PSP. And this port D act as a PSP only when PSP mode bit was set in TRISC. TRISC is data direction register of port E. In that we have a bit PSP mode bit. By making up that bit is equal to 1, then and only your port D is act as parallel slave port PSP. The time your RD0 to RD7 is act as PSP0 to PSP7 signal. Otherwise, it is simply used as an IO port for the connection of IO devices. That you have to remember, friends. And coming to the next, that is about port E. Port E size is equal to 3-bit IO port. I am already told you. It has only 3 pins. That is RE02, RE2. So it is a simple IO port of size of 3 bits. Again, to program these 3 signals, either input signals or output signals, that we do with the help of its own data direction register, which is TRISC. TRISC. By making of a bits in this TRISC is equal to 0, the corresponding pin of this port E is defined as an output. Whenever a specific bit of TRISC is set to 1, the corresponding pin of this port E is defined as an input. Along with that, this TRISC have one more bit that is called PSP mode. By using that bit, we can go and make our port D as a parallel slave port PSP. So that is also there. And coming to the alternate functions of your port E, the port E have two different alternate functions. One alternate function is these three signals are act as analog input signals, and another function is these three signals are act as control signals as well as chip select signals whenever port D is defined as parallel slave port PSP. See here friends, that's here I was mentioned. The alternate function of port E here RE0 slash RD bar slash A in 5 and your RE1 slash WR bar slash A in 6 and RE2 slash CS bar slash A in 7. So that's why here what I am saying is these are RA0 to RA2. These are three signals have a dual function. These RE0 to RE2 are act as AIN 5 to AIN 7. Whenever the port A signals alternate function is RA0 to RA4 we are getting from port A. Because internal to your PIC 16F877 we have a 8 channel 10-bit ADC is there. Whenever that ADC was activated, it will collect 8 analog inputs from an external world. At the time, 5 analog inputs it can receive with the help of port A signals and remaining 3 analog inputs it will receive with the help of port E signals. You remember whenever internal ADC was activated, the time these signals are act as AIN 5 to AIN 7. Analog input 5 to analog input 7. This is one. And another one is whenever your port D is act as PSP, parallel slave port, the time the same signals RE0 to RE2 are act as RD bar to CS bar. So here actually I was using prime. So prime indicates act to low signal. That prime can also call as bar. So RD bar as well as WR bar as well as CS bar. So on parallel slave port either I can do a read operation. That time this signal was activated. Sometimes you are doing a write operation. That time it was activated. Whenever if I want to do either read or write, definitely first of all the port must be active or it must be selected. That was done with the help of this chip select signal CS bar. So these are port E signals RE0 to RE7 may act as this. These we can call as a control signals. Control signals of port D when it is act as a PSP along with our chip select signal CS bar. So that you have to remember. So that is what I was mentioned. So that is digital inputs. So whenever we are not used port A as analog inputs, that time simply these are used as digital inputs. So I hope you understand guys about the IO ports of PIC 16F877. Once again I will give a brief. That is this particular controller has total 33 IO pins. Those are organized into 5 IO ports: port A, port B, port C, port D, port E. Port A consists of 5 IO pins. Sorry, 6 IO pins. Those are RA0 to RA5. Port E has just only 3 pins: RE0 to RE2, and remaining 3 ports: port B, port C, port D. Each one have 8 signals. So like that, 33 IO pins are organized into 5 ports. Each and every IO port has its own data direction register, DDR. By using that data direction register, we can program the port signals, either input signals or output signals. Whenever a particular bit of data direction register is set to 1, a corresponding port pin is defined as an input. Whenever data direction register bit is set to 0, a corresponding port pin is defined as an output. And we can also go through that. What are the different alternate functions for this IO pins of PIC 16F877? So I hope you understand IO ports of PIC 16F877. Thank you for patient listening. In the next class, I am going to discuss about another topic. Thank you very much.